5 takes us into logs, okay, even more. And we are learning some specific log properties, okay? I've talked about a little bit of log properties as we've gone along, and I don't think we learned the specific one I'm thinking of today, but we're going to learn some log properties. So we've got 3 of them here to talk about. These log properties specifically apply basically if positive parts. So for positive numbers b, m, and n, and b cannot be 1, the following properties hold. So basically you can't have a base of 1, and then the base has to be positive, as do the insides of the log have to be positive. So first of all, we have something called the product property, okay? The product property says that if you have a product inside the log, so notice m and n are being multiplied, that you can take that product within the log and split it up into 2 logs being added. So the log of m times n can be rewritten as the log of m plus the log of n, obviously keeping the base the same. Okay, an example, log base 3 of 5x. Well, we know that 5x is the same as saying 5 times x. So I can break this up and rewrite it as the log of 5 plus the log of x. Okay, just like you have a product property, you of course have a quotient property. So this is division within a log. Can be, if there's division within a log, it can be broken up into 2 logs being subtracted. So there you have log of m divided by n, and that can be log of m minus log of n. And again, keeping the same base. So the example here, log base 2 of 7/3 is the same as saying log base 2 of 7 minus log base 2 of 3. Okay, and these are properties that can be used when we go into solving equations, things like that, which will be next lesson, if I recall correctly. These are properties that we might have to use. And our final property in this setting is the power property. And this power property, so here we're looking at the power on the inside of the log, so log base b of m to the n. The power property allows us to take that power and move it out front as a coefficient. And so then that can read n times log base b of m. Okay, you can also do this the other way, in that if you have a coefficient out here in front of the log, you can move it up to the power. Okay, so for example, log base 5 of x to the 4th, that 4 is the power in the log. It can move out front, and so you have 4 times log base 5 of x. Okay. Okay. We're going to practice on the front side of these notes. We're going to practice using these logs. We've got 2 different ways to go with this. Okay. We're going to start on this top part about using the properties to expand each expression. So you have one log expression, and we're going to use our product, quotient, and power to possibly break them into multiple pieces. Okay. The bottom, we will condense them into 1. So as we look at log base 5 of a to the 2nd, b to the 7th, my job is to expand this. What do you see happening within the log right now? What do you see? There's multiplication, yes? Okay, this is the log base 5 of a to the 2nd times b to the 7th. Multiplication within a log. What can multiplication within a log do? It can break down into 2 logs being added. So that's the first thing we're going to do, is we're going to rewrite this as log base 5 of a to the 2nd plus log base 5 of b to the 7th. So we took that multiplication there within and expanded it to be the addition of 2 logs. Now, in order for this to be expanded the most, if I can make that, vocabulary there, there's one other property we can apply. And what property can we apply there? No. Okay, power property. Both of these logs, it wouldn't have to be both, but it is in this case. There's an exponent, yes? The power property says if you have a power, it can be rewritten as a coefficient out front. So that means this log base 5 of a to the second, where can the 2 go? It can go out front in front of the log. Log base 5 of b to the 7th, where can the 7 go? It can go out front as well. So this can be rewritten as 2 times log base 5 of a plus 7 times log base 5 of b. Okay? Do work to try and get those bases smaller, if that makes sense. And then since our job was to expand, we've expanded this as far as we can. Okay? We separated logs to the best that we can, and we've also moved powers out front. Questions? Okay. As I said, today it's learning the properties. Eventually you'll be using the properties. Today it's just practicing how do they work. Okay, B. Natural log of 25/3. Natural log is still a log, isn't it? Yeah, it's just a different base. So these same properties, even though they're written with log base 3, 2, and 5, still applies. It's just log base E. What's the first property I can use here? Quotient. If you have the log of division, it can be rewritten as 2 logs being subtracted. So how am I going to rewrite this? Natural log of 25, and then what? Minus natural log of 3. Now, what if I say there's one more thing we can do?
I believe.
You believe me, but do you know what it is? And I'll tell you, something has to be rewritten in for it to be more visible, but there's another property that we're going to be able to use here. Power property? Maybe I don't need to ask my next question. How could I use the power property? I'm not sure if you guys are saying the right thing or not. My question is 25. What do your brains know about 25? Okay. So I could, for the moment, 25, rewrite it as 5 to the 2nd, correct? Do you see where I'm going with this? Okay, 25 is the same as 5 squared. So 25 can be rewritten as a power. With that, by writing a power, I just wrote in an exponent. What's our power property say? You can take that power and move it out front. So in our case, we're going to take the 2 and move it out front. So if I move that 2 out front, what does this look like? 2 natural log of 5 minus natural log of 3. Okay. Okay, so you've seen all 3 properties used. Obviously, it's not going to be unusual to have multiple properties happening within a problem. Okay. C. Log base 7 of r to the 3rd t to the 4th over v. Well, several things to be done here. What's the first thing? What did I hear? Heard it somewhere. I just don't even know where. Huh? Quotient? I'll take quotient. And as I said, we're going to end up using all three of these rules. I don't know if you guys see it yet or not, but we're going to end up using all three. The overall thing that's being done within that is there is division, yes? A log with division inside can be rewritten as 2 logs being what? Subtracted. So log base 7 of, we're going to put that whole thing there, r to the third, t to the fourth, minus log base 7 of v. Do notice, to be official, I did put r to the third, t to the fourth in parentheses, because that does all go with the one log. Okay, so we saw a fraction, we undid it. We made it 2 logs being subtracted. What's next? Not yet on the power property. Okay, multiplication. And here's why, just to clarify. I'm not ready to talk power property because there's not just one power on this log. Okay? In order to talk power property, that power has to be on the entire inside of the log. And it's not. Okay? So that's why I'm not going to talk that. But you saw multiplication, right? So log of r to the third, t to the fourth can become log of r to the third and log of t to the fourth. And what are those 2 logs being done to? They are being added. So log base 7 of r to the third plus log base 7 t to the fourth and then still minus log base 7 of v. Am I done? No. Now what do we get to use? Now I am ready to use the power property. The 3 on the r can go out front. The 4 on the t can go out front. And the v is just along for the ride. So 3 times log base 7 of r plus 4 times log base 7 of t minus log base 7 of v. Okay. Okay. One more. Natural log of 7x over 225. What do you see first? A quotient? Division, yes. So what are we going to do? We're going to take this division and log with division inside can be rewritten as 2 logs being subtracted. So we can say natural log of 7x minus natural log, whoops, I said natural log, I didn't write natural log, minus natural log of 225. Okay, what do you see? What? Okay, so which way do I want to take it? So what do we know about 225? It's a perfect square, yes? 225 is the square of 15? Or I mean, yeah, 15. Okay, so this natural log of 225 can be rewritten as the natural log of 15 squared, yes? I was trying to decide which way I wanted to go with this, because my answer key has it slightly different. Okay. Before we move on, what about natural log of 7x? What about that? Yeah. 7x is 7 times x, right? So if that's 7 times x, this can be rewritten as the natural log of 7 plus the natural log of x. Okay. Keep going. The 15 squared. Okay, put that power out front. So we're going to have natural log of 7 plus natural log of x minus, and we're going to take that 2 out front, aren't we? And 2 natural log of 15.
Yep.
I wish I remembered the specific examples in your homework. Whether they would give, because okay, so I'm not against us stopping here. I'll be honest, in my notes I actually went a slight different direction. I took the direction you guys took me because that's good. You follow it, that's good. So, if we look at 15, what do you know about 15? 15 is what times what? 5 times 3, yes? Okay, so in my notes, I had actually had this broken up, and it's kind of awkward to do with the 2 there, but 225, you guys saw it as 15 squared. That's good. I like it. But another way to see 225 is that it is 25 times 9. And if you think 25 times 9, that is 5 squared and 3 squared. So, now, as I said, I'm comfortable with this. If we wanted to leave it like this, I'm going to show, and actually, okay, so I'm going to say that's an option. I don't know if Savas is going to have any issues like this, and this is where I wish I remembered exactly how the examples, how far they went. But the other thing we know is that 15, we just said is 5 times 3, yes? So if this is natural log of 7 plus natural log of x, what you can do here, 2 natural log of, whoops, 5 times 3, I could break that into 2 separate logs there. Now, technically, I shouldn't do it with the 2 out front, but we've already hit that point. So the other answer I could give here is natural log of 7 plus natural log of x minus 2 natural log of 5 and minus 2 natural log of 3. As I said, I'm fine with that. We have to watch out for Savas. Now, and I don't remember going forward like chapter review worksheet test as I finalized, well, the review worksheet I have done. I haven't finalized the test, so I will have to figure out that I don't think there'll be anything with this catch on it, so to speak. So it shouldn't be too big of a deal, but it's one of those things. I feel like I'm not doing my job if I don't show it to you. Okay. Now, do we have a handle on these 3 properties? Okay. We've used the product, the quotient, and the power property to take a single expression and basically unpack it, right? Expand it into multiple pieces. Okay, always using the product or quotient property first and then the power property at the end. Now, keep that in mind, what I just said, right? Product or quotient first, and then the power property. Because down below, we're going to reverse this, okay? So now, we have log expressions, which are multiple logs being added or subtracted. And we're going to reverse this, and our job is to write each expression as a single logarithm. Okay, sometimes I've seen the word condense because we're trying to take multiple logs and condense them. Now, so on first example, 4 times log base 4 of m plus 3 times log base 4 of n minus log base 4 of p. If I suggested previously that we're going to go the opposite way we were just going, what do you think should be that first step? The power property. Now, so if we're reversing the power property, what's that mean we're doing here? This 4 goes to the property instead of being a coefficient. The 3 goes to the power instead of being a coefficient. And the invisible one, doesn't technically need to move. So let's rewrite that first. So log base 4 of now it's going to be m to the 4th plus log base 4 of n to the 3rd minus log base 4 of p. Okay, so that was our power property. Now what? Product property. Do we see a couple of logs being added? 2 logs being added are going to be able to be rewritten as one log where the insides are multiplied. And I will say, when you see adding and subtracting, I would probably encourage you to go for the product property first before you do quotient property. So these 2 logs here, yes? How am I going to rewrite this? Log base 4 of what? Okay. Log base 4 of m to the 4th, n to the 3rd. Because 2 logs being added can be rewritten as one log where the insides will be multiplied. And then we still have minus log base 4 of p. Okay. So now we're down to just 2 logs being subtracted. 2 logs being subtracted can be rewritten as one log where the insides are divided. And that's our quotient property. So, log base 4, notice I kept that base all along the same time. You're going to have one big fraction, m to the 4th, n to the 3rd, divided by p. Okay, questions of how we got there? Can you get there on your own? Maybe with some practice. Okay, let's try B. 3 natural log of 2 minus 2 natural log of 5. What is your step 1? Power property. And here's what I'm going to say. Don't try and use product or quotient if you have numbers out in front. Get those numbers out of the front first. So power property says this 3 and this 2 go to the powers. So this rewrites as natural log of 2 to the 3rd minus natural log of 5 to the 2nd. Can we go ahead and do some math there if we wanted? Yeah, they're probably going to have gone ahead and done the math. What do we know about 2 to the 3rd? It's 8. So natural log of 8 minus, what do we know about 5 squared? So minus natural log of 25. And quotient property, yes. 2 logs being subtracted can be rewritten as 1 log where the insides are divided. So natural log of 8 divided by 25. Tell me, does 8 over 25 simplify? No. I ask that though because if it can simplify, should you simplify? Yes. Okay. It doesn't this time, but if it does, I want you to. Okay. Continuing along. Okay. Ask questions if you have them. C. I see a lot of people starting on that. That's good. 2 log 10 plus 4 log 3x. Okay, so you guys are working on your power property, yes? 2 is going to move to a power of 10. The 4 is going to move to a power of 3x. So, log of 10 to the second plus log of 3x to the 4th. What? I don't understand what you're saying. Oh, okay, okay, work the exponents out is what you're saying. Okay. I wasn't processing what you were meaning. Okay. Log of 10 squared. Can we go ahead and take that another step? Yeah, 10 squared is log of 100. Plus. Now, log of 3x to the 4th. Notice I have that 3x in parentheses, and then the power to the 4th. Is there anything I can do there? What's this 4? This 4 is on the x, but it's also on the 3, isn't it? So if I am working this out, so to speak, x to the 4th, okay, what's 3 going to be? 81. 3 to the 4th. 3 times 3 is 9. Another 3 times 3 is 9. 9 times 9 is 81. So this could also be rewritten as log of 81 x to the 4th. And you could get away without parentheses if 81x to the 4th is written as one quantity, but okay. And where are we going next? Okay, got that product property, right? 2 logs being added can be rewritten as 1 log where the insides are multiplied. What are you writing? Okay. Log of 100 times 81x to the 4th. Can we go another step with that? What is 100 times 81? 8100? 8100? So I can actually rewrite this as log of 8100 x to the 4th. And again, something like this, 81x to the 4th, it looks like one quantity, right? You could write this without parentheses as long as you're careful. You can also put parentheses. I really don't remember how Savas feels about parentheses. They may automatically have you put parentheses. I don't remember. So, okay, 2 more. 1/3 natural log of 27 minus 3 natural log of 2y. Okay, you guys working on powers? 1/3 goes as a power, and 3 goes as a power on their respective pieces, yes? So natural log of 27 to the 1/3 power minus, realize that minus sign is just staying there, right? We're not taking it with the 3. The minus natural log of 2y to the 3rd. Okay. What would you like to do next? Can we clean that up a little bit? What does a 1/3 power mean? Do you remember?
-3rd.
No. Not with the 1/3. Not a fraction. Or 1/3 is a fraction, but it doesn't make it a fraction. Huh?
Instead of square, instead of cube root, it's like cube root of.
Okay. So we talk about natural log of 27. If you remember, a 1/2 power is a square root. A 1/3 power is a cube root. Do we know the cube root of 27? We should. Cube root of 27 is? I left a lot behind this for you, guess. Okay. Cube root of 27 is 3. Yes? Did we figure that out? Okay. That goes back to, let's see, gold paper is this unit, so that goes back to the blue paper, yes? Or the gold paper can be helpful because 3 to the 3rd is 27, so back it up. Now, minus natural log of 2y cubed. What's going on here? Yeah, that 3 goes on everything, so it goes on the 2 also. So that's going to be natural log of 8y cubed. So now I have natural log of 3 minus natural log of 8y cubed, which means okay, 2 logs being subtracted can be rewritten as a division. Natural log of 3 over 8y cubed. Can I clean up 3 over 8y cubed? No, I can't. Okay, guys. Can we get through this one real quick?
Yeah.
Okay, we can do it. First step. Power property, yes. Okay, so rewrite them. 8 log base 3 of 2 becomes log base 3 of 2 to the 8th. 5 log base 3 of c becomes log base 3 of c to the 5th plus log base 3 of d to the 7th. Okay. 3 logs being added. Okay. At some point, you're going to want to say, what is 2 to the 8th? And 2 to the 8th is 256, you said? So this is log base 3 of 256. Still having log base 3 of c to the 5th. And still having log base 3 of d to the 7th. We're used to saying 2 logs being added. Rewrite them as 1 log where the insides are being multiplied. Can you do 3? Yeah. Doesn't work that easy with division, but it does with multiplication. So log base 3 of 256, c to the 5th, d to the 7th. You could get away with or without the parentheses there as long as you're careful and you make it all one piece. Okay? Tomorrow, we'll talk change of base formula, which requires your calculator. Okay? So we'll talk that tomorrow. You should have some work time tomorrow. Don't forget, 6.4 is due today. So get 6.4 done, you can start working on 6.5, and we'll go from there.